children, welcome to Zero Panic Maths. Today in this session we are going to continue with the exercise 1.1 of chapter 1. But before you start watching this video, I recommend you to watch the previous video on the introduction of the real numbers and the fundamental theorem of arithmetic, because the knowledge on that video might help you in understanding the problems in the exercise. Okay, done. So continuing on the exercise 1.1 of chapter 1. We start with the first problem. The first problem says express each number as a product of its primes. Now, as you might be knowing, any composite number can be represented in the form of a product of its prime factors that we have studied it in the last session. Okay, and the method used to find out the product of its prime factors is known as factorization method, and that is done through division by the prime numbers. Okay, so let us start with the first problem. The number given here is 140. Okay, so let us start with the lowest prime number 2. Okay, is 140 divisible by 2? Yes. So 2 sevens are 14, 0 remains. Now still 70 can also be divisible by 2. 2 threes are 6, 1 remains, 2 fives are 10. Okay, now can I divide 35 by 2? No. I can I divide it by 3? No. I can divide it by 5. So 5 sevens are 35, and finally 7 ones are 7. Okay, so I got 1 as the reminder, so I should stop the prime factorization. So how can I write 140 as the product of its prime factors? It's very simple. 140, therefore 140 is equal to 2 to the power of 2, because 2 is appearing twice, multiplied by 5 multiplied by 7. Okay, 2 to the power of 2 is 4, 4 5s are 20, 27s are is 140. Okay, that is the solution for the first problem. Now let us continue with the second problem. 156. Start with 2 as its first factor. 2 sevens are 14, 1 remains, became 16, 2 8s are 16, it can still go with 2, 2 3s are 6, 1 remains, 18, 2 9s are 18. Can 39 be divided by 2? No. Can 39 be divided by 3? Yes. 3 1s are 3 and 3 3s are 9. 13, since 13 itself is a prime factor, it cannot have any other factor other than this. Okay, so 13 ones are 30. So this is the prime factorization of 156. Very simple. Therefore we'll write the prime factorization 156 is equal to 2 to the power of 2, because as you know 2 is appearing twice here, 3 the product, and finally 13. If you see the multiplication of this, you're going to get the exact value as 156. Now let us continue with the third number, 3825. 3825. Now again start with the can I start with the lowest prime number 2? Can 2 divides this number? No, because it ends with 5. Can 3 divide it? Okay, let us try. 3 ones are 3, 3 twos are 6, and 2 remains. 3 sevens are 21, 1 remains, it became 15, and 3 fives are 15. Again I'll take 3, 3 fours are 12, 3 twos are 6, 1 remains, 3 fives are 15. Now I'll directly go with 5. 5 8s are 40 and 5 5s are 25. I'll still go with 5. 5 ones are 5 and 5 3 remains 35. 5 sevens are 35. Okay, so 17 itself is a prime number, so I'll go with 17 ones are 17. So what exactly is the prime factorization of 3825? Let me write it here. 3825 is equal to 3 to the power of 2, 5 to the power of 2 and 17, you can say, to the power of 1. So this is the product of 3825. Okay, let us continue with the next set of uh, exercise problems. Fourth and fifth, we're going to see this. Okay, now let us have 5 0 0. Now as you can see it clearly, it goes directly with 5. 5 ones are 5 0 0. 5 ones are 5. Can I divide still by 5? No. Can I divide by 7? Okay, 7 ones are 7, 3 remains and it became 30. 7 fours are 28, 2. Okay, I can go with 7. Okay, 7 ones are 7, 3 remains, it became 30. So 7 fours are it is 28, 2 remains 21, 7 threes are 21. Okay, now can I go with any other number, or I should see whether 143 itself is a prime number? Okay, it'll go with 11. 11 ones are 11, 3 remained and 33. 11 threes are 33. 13 itself is a prime number, so 13 ones are 13. So what is the prime factorization of 5005? 5005, the prime factorization of this is 5 into 7 into 11 into 30. Okay, so this is the prime factorization of this. Okay, now let us continue with the problem 5 of exercise 1.1. 7429 is the value. Now if you see at the value, it is little bit difficult to find out the proper prime factor of this, but if you go on verifying one after the other, see 2 cannot be the prime factor of this because it ends with 9. If you continue with 3 2s are 6 and 3 6 are 12, 2 remains and 3 7s are 21, but it become 19. So continuing in this way, finally you will come to a point where 17 is the minimum most prime factor of 7429. Okay, so it should be done through the trial and error method only. So let us continue with the prime factorization of this. 17 twos are 38, 17 threes are 54, 17 fours are 68. Okay, it is nearer to 74. 17 fours are 68, 6 remains, it is 62 and 62 62. So 17 threes are, what is 17 threes are? 51, it is 11 remains. 17 threes are 51, 11 remains, it became 119, and 17 sevens are, it is 119. Now 17 cannot also be the factor of this, so I'll go with the next prime factor of this, which is 19. 19 twos are 38. So among 43, 38, 5 remains 57. That is 19 threes are 57. So 23 itself is a prime number, 23 ones are 23. It is little bit different from the others, okay, but with trial and error method you can find out. Therefore 7429 is represented as its prime factors 17 multiplied by 19 multiplied by 23. It is the prime factor of this. Okay, that's all on the exercise 1.1 and section 1. Okay, let us continue with the section 2 problems. Okay, now what is the section 2 problem says? Find the LCM and HCF of the following pair of integers and verify that HCF multiplied by LCM is equal to the product of the two numbers. This, as I already told you, that uh, uh, the formula of HCF multiplied by LCM is equal to the product of the two given numbers. We have discussed in the previous video. You can watch that video to understand this. Okay, but anyway, we are going to continue the verification of the same formula here also. What are the two given numbers? 26 and 91. Okay, let us continue with the prime factorization of 26 first. Okay, 26, I'll go with 2. 2 ones are, 2 threes are. Okay, it is 13 itself is the prime factor, so 13 ones are. Okay, so what exactly is 26? 26 is equal to 2 to the power of 1 and 13 to the power of 1. 91, I'll start with 91. So 91, as you can see, it cannot go with 2, 3, 5, 7. Okay, so it will go with 7. I'll go with 7. 7 ones are 7. 2 remains. 7 threes are 21. So again, you got 13 and 13 ones are 13. Okay, let me erase this. So what is 91? 91 is also 7 to the power of 1 and 13 to the power of 1. Okay, now after finding out the prime factors of 26 and 91, we are going to find out HCF and LCM. Now, as you know, what is HCF? Using the prime factorization, HCF is take out the common factors with lowest powers. Okay, what are the common factors here? 13 is the common factor. 2 is not found in both the factors. 7 is also not found. 13 is the one which is common in both the factors. So what is the lowest power? It is 1 only. So HCF of 26 and 91, 26 and 91 is actually 13. And what is LCM? It is the product of all factors with highest powers. Okay, so anyway, the highest power here is 1 only. So taking all the factors, 2 multiplied by 7 multiplied by 13 will get us the LCM of these two numbers. Okay, so LCM of 26 and 91 is actually 2 multiplied by 7 multiplied by 13. 2 multiplied by 7 multiplied by 30. So what exactly is that? 2 sevens are 14, 14 3 13s are, okay, 14 into 13. It is 13 tens are 130, 13 fours are 52. It is 182. Okay, so the LCM is 182. Now Finally we need to verify whether HCF multiplied by LCM is equal to the product of the two numbers or not. Okay, let us do that. Okay, what is LCM? 13. So verifying HCF multiplied by LCM is equal to A multiplied by B. Okay, where A is 26 and B is 91. Okay, what is HCF? Is 13. What is LCM? Is 182. Whether is equal to 26, 91, the product of 26 and 91? Yes, let us see that. Okay, so you will get the value of this as, let us 2366. So you're going to get this also as 2366. So hence the verification done. Okay, let us continue with the next problem. Okay, the next problem is finding out the LCM and HCF of the pair of the integers given 5, 10, 92, and verify the same formula. HCF multiplied by LCM is equal to product of the two numbers. Let us start with the prime factorization of 5, 10 first. Okay, 5, 10. Okay, I'll go with 2. 2 2s are 4, 1 remains, 2 5s are 10, and 2 5s are 10. Okay, I'll go with 5. 5 5s are 25, and 5 1s are 5. I'll go with 3. 3 1s are 3, and 3 7s are 21. So what is 17? 17 itself is a prime number. So 17 1s are 17. So what is 5 10? 5 10 can be represented as 2, 3, 5, and 17. Okay, let us highlight this. Okay, now similarly I'll go with the prime factorization of 92. Okay, start with 2. 2 4s are 8, 2 6s are 12, 2 2s are 4, 2 3s are 6. Okay, so and since 23 itself is a prime number, 23 1s are 23. So what is 92? 92 is 2 to the power of 2 multiplied by 23. Okay, you need to now find out the LCM and HCF by using these two prime factors and then verify the formula. Okay, let us do that. HCF of 5 10 and 92. So as we all know, what is HCF? HCF is common factors with lowest powers. What is the common factor here? 2 is common. Anything else? No. 2 is common. And what is the lowest power? It is 2. Okay. So HCF of 5 10 and 92 is 2. So 2. Okay. Let us continue with LCM. LCM of 510 92. What is LCM? LCM is all factors with highest powers. The highest power of 2 is 2 to the power of 2, which is 4, multiplied by 3, 5, 17, and 23. It is actually multiplication of all those. 3, 5, okay, 3, 5, 17, and then 23. Okay, 4 3s are 12, 12 5s are 60, into 17 into 23. Okay, so finally if you get the multiplication of this will sum up to 23460. Okay, so 23460 is LCM of 510 and 92. Now we need to verify the product of HCF and LCM is equal to the product of the two numbers or not. Okay, let us do that. What is HCF? It is 2, and what is LCM? It is 23460. Okay, we need to verify whether it is the multiplication of 510 and 92. It should be, okay, because that is the proved formula. So twice of 23460 is actually, okay, 23 is 46, it's 920, 46920. Okay, hope this is the answer, and I can directly write it is 46920. Okay, let us move on to the next problem. The third problem in the second section, 336 and 54. We're doing the same thing here also. 336, start with 2, 2 ones are 2, and 3 remains, 2 6s are 12, and 2 8s are 16. 2 8s are 16, 2 4s are 8. 2 4s are 2 2s are 2 2s are 2 1s are 3 7s are. Okay, or finally you can write it as 336, or else I will write it here only. 336 is equal to 1 2 3 4, 2 to the power of 4, 3 and 7. 2 to the power of 4, 3 and 7. Let us do the same for 54 as well. 54, start with 2, 2 2s are 4, 2 7s are, start with 3, 3 9s are, again with 3, 3 3s are, and then finally with another 3. Okay, so what exactly 54 is represented as? 2 and 3 to the power of 3. 2 to the power of 1 and 3 to the power of 3. HCF of 336 and 54 is common factors with lowest powers. What is common factor? Common factors are 2 and 3. Lowest powers are 1 only. Okay, so 2 into 3, which is 6. Okay, now LCM of 336 and 54 is all factors with highest powers. Okay, highest power of 2 is 2 to the power of 4. Highest power of 3 is 3 to the power of 3, and 7 is 7 only. Okay, 2 to the power of 4. 2 2s are 4, 4 2s are 8, 8 2s are 16. Okay, and 3 3s are 9, 9 3s are 27 multiplied by 7. Okay, let us see what is the multiplication of 16, 27 and 7 comes up to. It will come up to 3024. Okay, now let us verify whether HCF multiplied by LCM is equal to the product of the two numbers. Okay, See, what is LCM? Sorry, what is HCF? 6 multiplied by 3024, which should be equal to the multiplication of 336 multiplied by 54. Okay, so what is 3024? 3024. Okay, let us multiply 3000 first with 6. That gives us 18,000. 18,000, 24 6 za 24 6 za is 120 plus 24, that is 144. So 18,144 is the value of this, and it should be also be equal to 18,144 if you verify it. Let us move to the next problem. Now let us continue with the third type of problems, where we're going to find out the LCM and HCF of three numbers with prime factorization method. Okay, till now we have found out the LCM and HCF for two numbers only and applied the formula also, but here we are going to find out the LCM HCF of three numbers together. Okay, so let us write the prime factors of 12, 15 and 21 first, find out the LCM and HCF. Okay, so how do I write 12? 12 is written as 4 multiplied by 3, and 4 I can write as 2 to the power of 2 and 3. Okay, similarly 15 I can write it as 3 to the power of 1 and 5 to the power of 1. 3 5s are 15. I can write similarly the 21 as 3 7s are 21. So these are the simple prime factors of 12, 15 and 21. Okay, we need to find out the LCM and HCF based on this. Okay, so as we all know that HCF is the common factors with lowest powers. What are the common factors in all the three? Is 2 common in all the three? No. Is 3 common in all? Yes. 5, 7 are also not common. So what is the common and what is the lowest? Common is 3 and the lowest power is 1. So HCF of 12, 15 and 21 is 3 to the power of 1, which is 3. You can even verify that also. 3 is the common factor for all these numbers. 3 4s are 12, 3 5s are 15 and 3 7s are 21. Okay, now similarly LCM of 12, 15 and 21. What is LCM? All the factors with highest powers. So highest power of 2 is only 2 to the power of 2, and the remaining all are having the powers as 1 only. Okay, now let us see that 2 to the power of 2, 3, 5 and 7 all with powers 1. Okay, 2 to the power of 2, which is 4, 3s are 5 and 7. 4 3s are 12, 12 5s are 60 and 16 7s are is 420. Okay,